Hello. So today I will be talking about gas chromatography and forensic science and the chemistry behind it. So what is gas chromatography? It is a technique used to analyze volatile compounds in a mixture, such as blood or urine, or in an arson investigations. It involves the use of a mobile phase, which is usually gas, and a stationary phase, which is usually a solid or a liquid. The instrumentation. Now there are multiple components to gas chromatography, and I'll be going over each of those in detail. We have a sample injector or sample port, a carrier gas, a column oven, and a detection systems. So, starting off with the sample injector or sample port. A sample port is necessary for introducing the sample at the head of the column. A calibrated microsyringe is used to deliver a sample volume in the range of a few microliters through a rubber septum into a vaporization chamber. Most separations require only a small fraction of the initial sample volume, and the sample splitter is used to direct excess sample to waste. Vaporization chamber is typically heated 50 degrees Celsius above the lowest boiling point of the sample, and subsequently mixed with the carrier gas to transport the sample into the column. Next is the carrier gas. The carrier gas must be dry, free of oxygen, and chemically inert. Helium is most commonly used because it is safer than most, but comparable to hydrogen in efficiency, has a larger range of flow rates that is compatible with many detectors. Nitrogen, argon, and hydrogen are also used depending on the desired performance and the detector being used. Both hydrogen and helium, which are commonly used on most traditional detectors such as flame ionization, thermal conductivity, and electron capture, provide a shorter analysis time and lower elution temperatures of the sample due to higher flow rates and low molecular weight. Carrier gas system contains a molecular sieve to remove water and other impurities. Carrier gas is preheated and filtered with a molecular sieve to remove impurities and water prior to being introduced to the vaporization chamber. A carrier gas is typically required in the GC system or gas chromatography system to flow through the injector and push gaseous components of the sample onto the GC column. Next is the column oven. The thermostated oven serves to control the temperature of the column within a few tenths of a degree to conduct precise work. The oven can be operated in two manners: isothermal programming or temperature programming. In isothermal programming, the temperature of the column is held constant throughout the entire separation. The optimum column temperature for isothermal operation is about the middle point of the boiling range of the sample. However, isothermal programming works best if only the boiling point range of the sample is narrow. In the temperature programming method, the column temperature is either increased continuously or in steps as the separation progresses. This method is well suited for separating a mixture with a broad boiling point range. The analysis begins at a low temperature to resolve the low boiling components and increases during the separation to resolve the less volatile, high boiling components of the sample. Lastly is the detection systems. The detector is the device located at the end of the column which provides a quantitative measurement of the components of the mixture as they elute in combination with the carrier gas. Detection properties fall into two categories: bulk properties and specific properties. Bulk properties, which are also known as general properties, are properties that both the carrier gas and analyte possess, but to different degrees. Specific properties, such as detectors that measure hydrogen phosphorus content, have limited application but compensate for their increased sensitivity. Two main parts: the sensor, which is placed as close to the column exit as possible in order to optimize detection. The second is the electronic equipment used to digitize the analog system so that the computer may analyze the acquired chromatogram. Ideal GC detector is distinguished by several characteristics. The first is adequate sensitivity to provide a high-resolution signal for all components in the mixture. The quantity of the sample must be reproducible, and many columns